Folks, today we're diving deep into a mind-blowing idea. What if time as we know it is just an illusion? Sounds crazy, right? But stick with me, it's simpler than you think. Imagine you're watching a movie. You see scenes unfolding one after another. But on the film reel, all scenes exist at once. Past, present, future, all there. What if our universe works the same way? Let's unpack this using Einstein's theory of relativity. First off, we all believe time ticks uniformly. Your seconds, my seconds, we think they're identical. But Einstein shook things up. He proposed that time and space are intertwined. Space-time. Think of space-time as a stretchy fabric. Massive objects like stars and planets bend this fabric. This bending affects how time flows. Here's an analogy. Place a heavy object on a trampoline. It creates a dip. Roll a smaller object nearby, and it spirals towards the big object. Similarly, massive objects warp space-time, affecting the flow of time. Now imagine you're on a fast-moving train. Your friend stands on the platform waving goodbye. For you on the train, everything feels normal. But compared to your friend, your time ticks slightly slower. This phenomenon is called time dilation. The faster you move, the slower your time passes relative to someone stationary. Think about a GPS satellite orbiting Earth. It's moving fast and is farther from Earth's gravity. Its clock ticks faster than clocks on Earth. Engineers correct this difference. Otherwise, your maps would be way off. Crazy, isn't it? Now let's visualize this with a simple example. Picture two identical clocks. One stays on Earth, the other boards a spaceship. The spaceship travels near the speed of light. After a year, the spaceship returns. The clock on the ship shows less time passed than the one on Earth. It's like time travel to the future. This isn't science fiction, it's proven science. Remember the twin paradox? Imagine twins named Jack and Jill. Jack stays on Earth. Jill travels on a fast spaceship. When Jill returns, she's aged less than Jack. She might be 25 while Jack is 80. They started at the same age, but time treated them differently. Mind-blowing, right? Now let's talk about gravity's effect on time. Ever wonder why time passes differently in movies like Interstellar? They visit a planet near a black hole. An hour there equals 7 years on Earth. That's because the immense gravity of the black hole slows down time. Gravity stretches space-time, just like the heavy ball on the trampoline. Closer to massive objects, time ticks slower. Climb a mountain, and time speeds up, just a tiny bit. But over millions of years it adds up, so people living at higher altitudes age slightly faster. Not enough to skip your anti-aging cream, but still fascinating. Now, think about light. It's the universe's speed limit. Nothing can go faster. As you approach light speed, strange things happen. Your mass increases. Distances contract. Time slows down dramatically. It's like the universe is saying, hold on, slow down. Imagine driving a car. At normal speeds, distances and time feel constant. But push that car to near light speed and a trip across the galaxy might take minutes for you. Meanwhile, thousands of years pass on Earth. So whose time is the real time? Both are real in their own frames of reference. This brings us to the idea of simultaneity. Two events that seem simultaneous to you might not be for someone else moving at a different speed. Imagine lightning strikes at both ends of a moving car. An observer on the ground sees them happen at the same time, but a passenger on the car sees the front strike before the back. Which one is correct? Both are. Time isn't absolute, it's relative to the observer. Now let's stretch our minds further. If time is relative, could multiple realities exist? Think of life as a book. You read page by page, but the entire story exists at once. Past, present, future, all there in the book. Similarly, in a block universe theory, all moments exist simultaneously. We just experience them sequentially. This suggests that every possible event is out there, coexisting. Every choice, every possibility, like branches on a tree. Quantum physics supports this with the idea of superposition. Particles exist in multiple states until observed. It's like flipping a coin that lands both heads and tails until you look. Some scientists propose the multiverse theory, an infinite number of parallel universes where every possible outcome happens. In one universe, you took that job offer. In another, you didn't. All possibilities play out somewhere. Now let's bring it back to Earth. Have you ever noticed that time seems to fly when you're having fun and drags when you're bored? That's your perception of time being flexible. But Einstein showed that time itself is flexible. It's affected by speed and gravity. So next time you're waiting in line, remember, time isn't as fixed as that clock on the wall suggests. Now let's talk about practical applications. Without understanding time dilation, GPS technology wouldn't work. Satellites experience less gravity and move faster than us. Their clocks tick differently. Engineers adjust for this so your navigation is accurate. This complex physics makes everyday tech possible. Isn't that amazing? So is time an illusion? In a way, yes. It's a construct that depends on your frame of reference. There isn't a universal now that everyone shares. Your now could be someone else's past or future. That's a wild thought, but it opens up endless possibilities. Understanding this changes how we see the universe. It reminds us that reality is more complex and fascinating than we imagine. So what does this mean for us? It encourages us to stay curious, to question our assumptions, to explore the unknown. Because the more we learn, the more we realize there's so much more out there. So next time you check your watch, think about this. Time isn't just ticking away uniformly. It's a dynamic, flexible dimension intertwined with space. And who knows, maybe one day we'll harness this understanding to explore the stars, traveling vast distances without aging centuries. The future could be closer than we think. Thank you for joining me on this incredible journey. If you enjoyed, give us a like. Share this video with friends, they'll thank you for it. Leave a comment with your thoughts or questions. Let's keep the conversation going. And don't forget to subscribe for more mind-bending explorations. Until next time, keep questioning and stay curious. Because the universe is full of wonders waiting to be discovered.